Good morning, students. Chapter 7, AC current. Yes, in last lecture we have discussed about LC oscillations. Okay, yes, when capacitor and inductor they are connected, then what happens? Yes, energy oscillates between inductor and capacitor. Okay. Today's topic is transformers. Now, what do you mean by transformer? Yes, transformer means not Optimus Prime, okay, or Bumblebee. What is transformer? Here we will see in detail. So yes, first of all we will divide this question in 4 parts. That is principle. First of all it is requirement, then principle, then its construction, and then its working. Okay. So first of all, what is requirement of transformer? See, here it is. What is requirement? Requirement of transformer. See, in residential area or in industrial area, power means electricity is supplied from power station, and such power stations are at large distance from residential area or industrial area. Okay, so for example, it is power station, and yes, here it is residential area. Okay, and yes, we know that from power station, whatever electrical energy or power produced, it is supplied via or it is supplied through cables. Through cables. Yes or no? Yes. Okay, you have seen towers. So yes, electricity generated from power station is supplied to residential area or industrial area through kilometers long wire cables. Okay, and yes, they always have some resistance. So whenever current is passing from such conductors, according to I square RT, heat energy is produced. According to I square RT, heat energy is produced. Okay, yes, when current is flowing from these cables, and these cables are kilometer long. Okay, they are kilometer long. So obviously, yes, the resistance R is equal to rho L upon A. If the length is more, then obviously the resistance is more. So according to I square RT, heat energy is produced. Means whatever energy is supplied from power station, okay, its most of portion is lost as heat energy, and here we will have only small amount of energy. Okay, because according to I square RT, heat energy is wasted. Okay, so if here from this I have supplied 100 watt energy, 100 watt power, then here it will be less than 100 watt. Okay, so how to reduce this heat energy? To reduce this heat energy, I have to reduce I, R or T. T we cannot decrease. R, that is resistance, again we cannot decrease. So yes, if we decrease I, but to maintain constant power, okay, what is equation of power? P is equal to, it is VI. So if I want constant power and if I am decreasing I, then obviously I have to increase V. So here it is one requirement. Okay, before you supply electricity to residential area, you have to put one device which increases voltage. Clear about this? Before you supply electricity power to residential area or industrial area, you have to first of all increase its voltage. So if voltage increases, current increases, but that power, that product, that is power, it remains constant. So yes, here one requirement is you have to form one device which increases voltage. Okay, now see, such high voltage current is passed through tall towers that we know. Okay, high tension line with the help of tall towers. Okay, now if this high voltage line, if this high voltage supply is directly applied or supplied to residential area, okay, then there is lightning in each and every home. Yes or no? So yes, here again we have one another requirement. We have one another requirement, that is, before we supply this electricity to each and every residential area, we have to decrease voltage. We have to decrease voltage. Clear? So here power station, electricity is generated. One device that will increase voltage. That high voltage current is then transferred. Okay. Then before supplying to residential area, you have to decrease voltage. You have to decrease voltage. Okay. And that decreased voltage is then supplied to each and every residential area. So what is requirement in this whole system? Yes, requirement is we have to increase voltage and decrease voltage. Okay. To increase voltage and decrease voltage. To increase voltage and decrease voltage. So yes, transformer is such a device which increases or and decreases voltage. Okay, a device which increases or decreases voltage is called transformer. Clear about this? So it is its requirement. Okay, what is requirement of transformer? What is requirement of transformer? Clear about this? Okay. Now we will see. Okay, what is its principle? What is its principle? What is its principle? What is principle of transformer? Yes, principle of transformer is mutual inductance. Its principle is mutual inductance, or you can also say it's based on electromagnetic induction, or you can say it is electromagnetic induction. Okay, so yes, it is its principle. Now what is its working? Yes, what is its construction? Yes, its construction. Now we will see its construction. What is construction of transformer? Yes, construction of transformer. See, here it is. There are two types of construction, two types of arrangement for transformer. First one, if we have one rectangular frame made up of iron like this. If we have one rectangular frame like this. If we have one rectangular frame like this, okay, made up of soft iron in terms of layers. Layers means one frame insulating medium, another frame insulating medium, one frame insulating medium. Okay, why to make such arrangement in terms of layers? Laminated board, to reduce effect of eddy current. Now, on this one side, one coil is wound. On another side, another coil is wound. Okay, so yes, in transformer there are two coils, first coil and second coil. Yes, this first coil, it is called primary coil. And it is called secondary coil. This primary coil, it is also called input coil. And the secondary coil, it is called output coil. So it is first type of arrangement. What is second type of arrangement? See, if it is like this, yes, one arrangement is like this. Okay, one arrangement see, in this case, primary and secondary coil, they are on different arms. Primary coil on first arm and secondary coil on another arm. But in this case, what happens? A primary coil and secondary coil, they are wound on the same arm. They are wound on the same arm. Okay, yes, it is primary coil. It is primary coil, and this side is secondary coil, and this side it is secondary coil. Okay, so yes, it is construction of transformer. It is construction of transformer. Okay, yes, we have two coils, primary coil and secondary coil. Primary coil and secondary coil, and such two coils are wound on different arms or on same arm. Clear about this? And yes, this material is made up of soft iron. So what happens? Now it is about construction. It is about construction. What is circuit symbol of transformer? Circuit symbol. What is circuit symbol of transformer? Circuit symbol of transformer is like this. It is like this. It is primary coil and it is secondary coil. Clear about this? So yes, it is construction of transformer. This type and this type. Clear about this? Now we are assuming, okay, like numbers of turns in this primary coil is NP, and numbers of turns in this secondary coil, it is NS. Here again it is NP, and this side it is NS. NP and NS, number of turns in primary coil and secondary coil. So now we will see it's working. Now we will see it's working. Okay, how it works. How it works. Working. Okay, see what is working of transformer. Here it is. Input means this electricity produced from power station is connected to primary coil. So in primary coil, AC current, that is alternating current, is flowing. Due to this alternating current in this coil, magnetic flux is linked. That magnetic flux through this core, it is linked with another coil, that is secondary coil. So again, in secondary coil, flux is linked. So it is AC current changes, magnetic field changes, magnetic flux changes. So there is also change in magnetic flux linked with secondary coil. Change in flux, EMF is induced between two ends of secondary coil. Simple. Again I will repeat. This primary coil is connected with source. So current is flowing from this primary coil, that is AC. So value of current continuously changes. So magnetic field also changes. So flux is produced, that also changes. And that flux is linked through this core. This flux is linked through this coil to this secondary coil. And yes, between two ends of secondary coil, EMF is produced. Simple. So that's why it is called mutual inductance or electromagnetic induction. In this case, yes, in this case, these two coils are wound on the same arm, So yes, in this primary coil, current is passed, magnetic field is produced, flux is produced, and that flux is linked with secondary coil. So yes, between two ends of secondary coil, due to change in flux, EMF is induced. Clear? And yes, in secondary coil, induced EMF, its value depends on numbers of turns. It depends on numbers of turns. Clear about this? Clear about this? So what is working? What is working? Yes, in working, how to write? In working, how to write? See, in working you have to write initially this primary coil is connected with input. Due to that, current is flowing, magnetic field is passed. Current is passed, magnetic field produces, flux is linked with another coil, and between two ends of another coil, current is produced. Between two ends of secondary coil, EMF is induced. Clear about this? So yes, it is working. It is working. Now, how to write in this working? So yes, we have to assume that numbers of turns, in primary and secondary coil, and secondary coil are NP and NS respectively. NP and NS respectively. Okay, we have assumed numbers of turns NP and NS respectively. Clear about this? Now, when primary coil is connected with source due to current in primary magnetic field and thus magnetic flux is induced and thus magnetic flux is induced and thus magnetic flux is linked with it. This magnetic flux is also linked with secondary coil through pole. This magnetic flux also linked with secondary coil through core. Clear about this? And due to change in flux EMF is induced in secondary coil. EMF is induced in secondary coil. Clear? So it's working. Now next one is equations for transformer. Okay, so now we will see equations of transformer. Okay, now equations for transformer. See, it is primary coil and it is secondary coil. Primary coil and secondary coil. Okay. Yes, we know working. When current is passed from primary coil, EMF is induced between two ends of secondary coil. Okay. So yes, EMF induced between two, or EMF induced in secondary coil. EMF induced in secondary coil, that is ES is equal to minus NS and d phi upon dt, where what is phi? Phi is flux linked with each term. Phi is flux linked with each term. So ES is equal to it is minus NS d phi upon dt. ES is equal to it is minus NS d phi upon dt. Clear about this? Okay. And yes, also back EMF induced. Also back EMF induced in primary coil. That is EP is equal to minus NP d phi upon dt. We are assuming a flux linked with each turn in primary coil and secondary coil is same. Flux linked with each turn in primary coil and secondary coil is same. So it is ES and it is EP. Now we have to assume resistance of primary coil is negligible. So yes, I can write EP is equal to VP. It is EMF and it is voltage. Okay, potential drop. Vp is equal to it is minus NP d phi upon dt. Also, let small current is produced in secondary coil. Let small current is produced in secondary coil. So again, yes, here ES is equal to PS and here it is minus NS d phi upon dt. Now small current means, if you remember, V is equal to E minus IR. V is equal to E minus IR. V is equal to E if IR is equal to 0. In this case, we have considered resistance of primary coil negligible. So R is equal to 0, so IR becomes 0. In this case, we have assumed small current is produced in secondary coil. Means I is equal to 0. So again, V is equal to E. Clear about this? So yes, it is Vp and it is Vs. Now if I take ratio of these two equations, I will get Vs upon Vp. I will get Vs upon Vp is equal to, see, Vs upon Vp. Vs upon Vp. Minus minus cut. It is Ns upon Np. It is Ns upon Np. Clear about this? So yes, it is first equation that you have to remember. It is first equation that you have to remember. That is Vs upon Vp is equal to Ns upon Np. Clear about this? Now, if we have ideal transformer. Now if transformer is ideal, it means for ideal transformer, input power is equal to output power. Input power is equal to output power is equal to, it is output power. Okay, so yes, for transformer it is input power is equal to output power, means loss of energy is 0. Loss of energy is 0. Loss of energy is 0. Okay, so yes, if transformer is ideal, input power is equal to output power. So input power means I can write it is IP Vp. In output power means I can write IS Vs. Clear about this? So now again, if I make Vs upon Vp as subject, then Vs upon Vp is equal to, it is Ip upon Is, and Vs upon Vp is also equal to, it is Ns upon Np. So now you have to remember this equation. Okay, Vs upon Vp, voltage in secondary coil, voltage in primary coil. Current in primary coil, current in secondary coil. Number of turns in secondary coil, number of turns in primary coil. Okay, so yes, this equation you have to remember. And now from this equation, we will see two conditions. See, first condition here. Case 1. If Ns is greater than Np. Number of turns in primary coil is greater than number of turns in secondary. So first of all, I am taking this equation, that is Vs upon Vp is equal to Ns upon Np. Now Ns greater than Np means this ratio is greater than 1. So obviously Vs is greater than Vp. Means voltage in secondary coil is greater than voltage in primary coil. Means voltage increases. V increases, and such transformer is called step-up transformer. Such transformer is called step-up transformer. Transformer in which voltage V increases is called step-up transformer. Transformer in which voltage increases is called step-up transformer. And yes, what is condition in step-up transformer? Ns greater than Np. That is, numbers of turns in secondary coil is greater than numbers of turns in primary coil. Ns greater than Np. So yes, Vs greater than Vp. What about I? Yes, Ip. Yes, Is is less than Ip. Clear about this? So yes, it is first case, that is step-up transformer. Now, what is second case? See, here it is. What is second case? Okay, if case Case 2. If Ns is less than Np. If Ns is less than Np. So obviously Ns, if I write this equation, that is Vs upon Vp is equal to Ns upon Np. If Ns upon Np, Ns is less than Np, so this ratio is less than 1. So therefore Vs is less than Vp. Means voltage in secondary coil is less than voltage in primary coil. So here voltage decreases. Voltage decreases. And such transformer is called, such transformer in which voltage decreases. Such transformer is called step down transformer. Step down transformer. Clear about this? So yes, but this thing is for ideal transformer. Okay, ideal transformer means no power loss. Ideal transformer means no power loss. Clear about this? So yes, transformer is one whole theory. What you have to remember, its requirement, its principle, its working, its construction, and such equations. Yes, we will see one extra point, that is, see here, Ns upon Np is equal to R, and it is called transformation. It is called transformation ratio. It is called transformation ratio. Clear about this? Okay, Ns upon Np is equal to R, and it is called transformation ratio. If R is greater than 1 and R is greater than 1, it is possible when Ns is greater than Np. So if R is greater than 1, it is called step up transformer. It is called step up transformer. Okay, and R is less than 1, so it is called step down transformer. So it is called step down transformer. It is called step down transformer. Clear? So this extra point you have to remember. Okay, what is step up transformer and what is step down transformer? Clear about this? So yes, transformer is one of the important theory of this chapter. So yes, take care about this theory, and it is easy one. Okay, now there is one last point. Okay, in ideal transformer, input power is equal to output power, means no loss of energy. No loss of energy. But in reality, there is loss of energy. So that loss of energy is due to which factors that we will see. Okay. Yes, in ideal transformer, input power is equal to output power, means no loss of energy. But in actual transformer, small energy losses due to some following reasons. First, flux linkage. Yes, flux linkage. What is flux leakage? What is flux leakage? Primary coil, secondary coil. Yes or no? Yes. Flux induced in primary coil is linked with secondary coil through this core. Yes or no? Yes. Flux produced in first coil is linked with secondary coil through this core. So yes, due to air space between core and coil, due to distance between two coils, okay, and due to such material, there is loss of flux. Means whatever flux is linked in this coil is not same in this coil. Means there is flux leakage. Okay. Second one, resistance of winding. Yes, in each and every conductor there is always some resistor. So in resistor, if current is flowing according to I square RT, heat energy is dissipated. Clear about this? So it is second one, that is losses, energy losses. Okay. Third one, eddy current. Yes, chapter number 6. We know that whenever conductor is placed in varying magnetic field. Okay. So yes, in conductor, in core, eddy currents are produced. eddy currents are produced. Circulatory currents, yes, we know. Okay, inside this core of material, eddy currents are produced, and due to eddy currents, again, according to I2RT, heat energy is produced. Next one is, and last one, that is hysteresis. Now, what is hysteresis? Yes, obviously it is AC current, and AC current means it continuously changes its direction. Now remember chapter number 5, ferromagnetism. Okay, when ferromagnetic material is connected with AC source means current changes its direction. And due to changing direction of current, there is also changing magnetic field. There is also changing magnetic flux. Okay, so yes, due to such AC current connected with this primary coil, one hysteresis cycle is formed, and we know that area enclosed by hysteresis cycle, it gives energy lost per unit area. Clear about this? So yes, in this case it is connected to AC supply. It continuously changes. So due to hysteresis produced, again there is loss of energy. So in actual transformer, small energy losses due to following reasons. Yes, this theory you have to write from your textbook. Okay, this theory you have to write from your textbook. Okay, what is flux leakage? What is resistance of winding, eddy currents, and hysteresis? Yes, you have to write this theory from your textbook. And for transformer, this is it.